You're standing at the edge of a harbor as a cruise ship the size of a floating skyscraper glides slowly toward the dock. It weighs well over 100,000 tons. It stretches longer than 3 football fields, and somehow, controlling this giant slab of steel is a tiny boat that looks almost ridiculous beside it. So how does that make any sense? How can something so small steer something so massive? Welcome to Exhaust Mechanic. Today we're uncovering one of the most underrated engineering marvels hiding in plain sight: the tugboat. Most people instinctively think size equals power. Bigger object, greater control. That feels obvious. But the moment a giant ship enters a harbor, that logic completely falls apart. A huge cargo ship or cruise liner does not behave like a car. It cannot simply brake, turn, and maneuver wherever it wants. In fact, at very low speeds, the ship's rudder becomes surprisingly ineffective because there isn't enough water flowing past it to generate strong steering force. The systems that work perfectly in the open ocean suddenly become clumsy and sluggish inside a narrow port. So once a vessel reaches harbor waters, it effectively becomes a massive floating object with very limited precision control. And that's where tugboats become essential. The secret is not raw strength in the way most people imagine. It's concentrated thrust, precise positioning, and total maneuverability. Tugboats are built around one purpose: producing enormous force from an incredibly compact machine. Even though many harbor tugs are only around 30 meters long, their engines can generate astonishing amounts of horsepower, sometimes more than ships far larger than themselves. But what really matters is something called bollard pull. Bollard pull measures how much pulling force a tugboat can generate while tied to a fixed object. A standard harbor tug can often produce 40 to 60 tons of pulling force, while larger ocean-going tugboats can exceed 200 tons. That is an incredible amount of concentrated power. Imagine dozens of fully loaded trucks all pulling together. A single tugboat can match that kind of force, and during docking, that force is applied with extreme precision. A tugboat is rarely just pushing a ship. At any moment, it may be slowing the vessel down, stopping the stern from drifting sideways, rotating the bow into alignment, compensating for tidal currents, and stabilizing the entire ship against wind and water movement simultaneously. It's less like a tow truck and more like a finely tuned control system. So where does this unbelievable maneuverability come from? A huge part of the answer is the propulsion system. Many modern tugboats use azimuth thrusters. These are rotating propeller units mounted beneath the hull that can spin a full 360 degrees. Unlike traditional ship propellers that mainly push forward or backward, azimuth thrusters can direct force instantly in any direction. That means the tugboat can slide sideways, pivot in place, move diagonally, or rotate while applying power all at the same time inside a crowded harbor. That agility is priceless, and when a massive container ship enters port, there usually isn't just one tugboat involved. There may be 2, 3, sometimes even 4 working together in perfect coordination. One controls the bow, another manages the stern, others stabilize the middle of the ship. Every tug captain stays in constant communication with the harbor pilot on board the vessel. Each movement is calculated. Each burst of thrust is deliberate. Together, the tugboats function as one coordinated precision system, applying carefully controlled forces from multiple directions to guide the ship safely into place. None of this is improvised. Docking a supertanker or cruise ship is a carefully planned operation that depends on local knowledge, timing, and physics. Harbor pilots specialize in the exact layout, currents, tides, and wind behavior of their specific port. They direct the tugboats with incredible precision because even a tiny mistake in a narrow channel can lead to catastrophic consequences. So the next time you watch a tugboat escorting a gigantic ship into harbor, don't think of it as a small boat overpowering a larger one. That's not what's happening. What you're really seeing is a highly specialized engineering machine operating in the one environment where the massive ship becomes vulnerable. The ship isn't weak, it's simply not designed for delicate maneuvering in tight spaces. And the tugboat, despite its size, is built exactly for that purpose. It uses concentrated power, perfect positioning, and an extraordinary understanding of physics to control something that could never safely navigate the harbor alone. The size difference may look dramatic, but in a port, control matters most, and that tiny tugboat has more of it than almost anything else on the water. If this completely changed the way you see those little boats beside giant ships, make sure to like and subscribe to Exhaust Mechanic for more videos that uncover the hidden engineering behind the everyday world.